Hi, welcome to MAT 100 Applied Math. We're going to discuss in this video 12.1 and 12.2. So 12.1 does reading and interpreting graphs, and 12.2 deals with measures of central tendency. And I think we can cover both in just one video briefly. So we're going to take a look at a couple of these things and see what we can do. So I'm not going to worry too much about constructing graphs, but we're going to look at one graph here. Let me fold this over just a little bit. Let's look at this first example. This is the example in your book. Just kind of wrote it down here. And in this example, what we're going to do is look at a vertical bar graph. Shows the average annual health care cost per person in 6 different countries. So if I can make this a little bit bigger, I don't know, try our best. Across here is what we would call the item that we're talking about, the different countries, Greece, and these are pretty small, but South Korea and so on, Italy and so on. And this column down here is what we would call the frequency, or the number of times this number came up. This is our amount of money that we're spending, but it's also the frequency, like this was at this amount. So that's the frequency at which this occurred, okay? It looks to me like this is divided up. Each one of these little marks here, if I can show you a little bit better, each one of these little marks right here is 500. So it's going up by 500, 1,000, and so on. So sometimes it's kind of hard to interpret these graphs because they are rather small, and it's kind of hard to sometimes read them. So anyhow, I try to, it's a little blurry, but you can look at your book on page 738. But what we're going to try to do is answer some questions about this graph, just a couple of things. So looking at this graph, the first question was, what is the average health cost per person in Germany in 2010? So a little difficult to see that one. Let's see if I can bring my book over. Might be just a tad bigger. Not great, but it's kind of a little bit bigger. And let's see if we can kind of interpret this graph. Germany, 2010. So that's when this was taking place. That's when the graph was. And sometimes they have a heading, see, various countries, 2010. If I can move this, I'm trying to move it over the other way, excuse me. All right. So it had a heading on it, and I'm trying to get this straightened out. Okay, there's another graph over here. We're not going to be concerned with it. So the first question is, what is the average cost? So we just look at Germany, but we have to interpret. This would be 4,000. This would be 4,500. So if we run a ruler across here to Germany, try to get it, we can see that that's not quite 4,500. So it's kind of hard to tell. Some people might say it's 4,400. Some people might say it's 4,300. So we can't tell exactly, but we're going to make an estimate. Germany, I'm going to estimate that it was 4,300 dollars. Okay, so that's how we do it. Second question. Question number 2 is, by what percent did the cost per person in the Netherlands exceed the cost of Great Britain? Well, let's find out what Netherlands is. Netherlands was slightly above 5,000. You might say 5,000. I'm going to say Netherlands was 5,100. Okay. And Great Britain. Great Britain, another one that's a little hard to interpret. Here's 3,500. It's almost at 3,500. You could probably say it's 3,500, huh? Maybe a little bit less. So I took Great Britain to be 4,400. Okay. I mean, 3,400. What am I saying? 3,400. Excuse me there. 3,400. Now, you might have caught it 3,500. That'd be pretty close. And you might have caught this 5,000. You know, so your figure is going to be off a little bit. So the question is, what percent did the cost per person in the Netherlands exceed that of Great Britain? So what I did is I subtracted these. I got 1,700. And then I took that number, and we want to know how much Netherlands exceeded Great Britain. So I'm going to divide by Great Britain. This is how actual number it exceeded it, but I want the percent. So I'm going to divide that by 3,400. And that's why if you use 5,000 and use 3,500, this might only be 1,500. And we're seeing what difference it would make. So 1,700 divided by 3,400. Gonna whip out the old calculator. Just put it over here. 1,700 divided by 3,400. It was about 50%, 0.50, and we want to change that to a percent, 50%. Let's say we just rounded this off to 5,000, and we rounded this off to 3,500. Okay, so we had 1,500. The difference between these would be 1,500 divided by 3,500. So 1,500 divided by 3,500 would be roughly about 43%, 0.43, 43%. So you can see interpreting these graphs isn't really an exact science. You know, sometimes when they do graphs like this, they actually put down the exact amount inside these bars. Then it makes it a little bit easier to calculate, or not, or at least close to the exact number. You know, they might put down, in here they would put down 3,400 or whatever it was. So it makes it a little bit harder. The book said it was 50%, so I think they went by my figures. But you know, if you go by a slightly different figure, you might come up a little different, and we can see that. So that's what we mean by interpreting a graph. Let's take a look at another graph. This is on example 3. Once again, maybe I can flip to this. Book, I believe it was at the bottom of the page. That was one. Here's example 3. And then what I did is I actually worked this out. So let me put the whole page up here, and then you can kind of see. This was gas consumption, cost of gas, and the gas taxes worldwide. The first part is the lighter shade is the tax on the gas, and this would be the price of the gas without the tax, and then the total height is the combined tax. So it says, what was the total cost for a gallon of gas in Canada? So if you look at your chart here, Canada, fortunately, Canada came out exactly at $5. So that one wasn't too hard to interpret. I'll put it a little bit bigger so you can see. So the answer was $5. In United Kingdom, what was the dollar amount per gallon represented by taxes? So this was in United Kingdom, that would be this. So we wanted the lighter shade of blue, and again, it came out an exact number. Let's put it down here and read across, $4 in taxes, $4. Then on number 3, it says, how much did it cost to fill up a 16-gallon tank in Turkey? How much more to fill up a 16-gallon tank in Turkey than it did in the United States? So when I looked at my graph, I'll make this a little bit bigger so you can see. Sorry about that. When I looked at my graph, here we go, in Turkey, I got $9.90. It wasn't quite $10. And again, it's an interpretation. So I said it was $9.90 in Turkey. And then I go back and see, I guess I skipped that. And then in the United States, I looked up United States, and that was, I interpreted United States as being $3.50. So then what I did is I multiplied $9.90, and I don't know if you can see this, but I'll write it a little bit bigger. I took the $9.90 in Turkey, write it up here and slide this down so I can read my numbers. $9.90, and I multiplied that by 16 gallons. It said they were going to fill up with 16 gallons. And in Turkey, that would cost, at this particular time, $158.40 is what I came up with. I think that was my numbers here. It's kind of blurry. And then I looked at the price of the United States. It was $3.50, which was rather high, but still a lot cheaper than Turkey. Multiply that by 16, and I came up with $56 to fill up. So the difference between these two means we're going to subtract them. $102.40 would be the difference between a fill up in United States and a fill up in Turkey. Okay, the last one said, by what percent? So it's asking for a percent. Did the total cost of a gallon of gas in the Czech Republic exceed the cost in Chile? So in the Czech Republic, gas costs $7 a gallon. And in Chile, still pretty high, $6.10. So the difference between these I came up with was 90 cents. 90 cents a gallon approximately. So it said, by what percent of the total gallon of gas in Czech Republic exceed? So I did this as the change divided by the starting amount to find the percent of increase. Got a percent of increase. To find this percent of increase, I took the change, which was 90 cents, and I divided it by the starting amount in Czechoslovakia, which was $7. And then I divided that off. 0.90 divided by 7. Let's see if I got it right. 0.90. 0.90 or 0.9 divided by 7. And I came up with 0.128. So if I want to write this as a percent, I just wrote it as 13%. So that would be our change, 13%. Okay, so that's how I did those problems, and I kind of computed them. And I didn't do Italy. Italy said what percent of the total cost per gallon was represented by taxes. So in Italy, the total cost was $8, right? I think I just, see, Italy, $9. That was the total cost. And the amount of taxes that they pay, I interpreted it to be $3.50. You know, and again, these are just interpretations. So it said, what percent is the tax of the total? So what I'm doing is I'm dividing the tax by the total to get a percent. And again, I took 3.50, divided it by 9, and I got 0.38. And I rounded it off to 0.39 actually. So I said, well, that's about 39%. And I think that's what the book came up with the answer to, about 39%. So they give you the answers, but they don't tell you how they got the answers. So that's how I did these things. So this was here's a C problem. This was the fill up. This was the D problem right here. And this problem right here was the E problem, kind of sloppy. Swing it around here. So this was the E problem. So it's just a matter, your graphs might not be as hard as this one. It's just a matter of reading graphs. I have one more graph I want to go over real quick. And that's this graph over here. It had to do with tires. So let me put this up here so you can see the graph a little bit. And let's see what the question was. Okay, so the first question, just grab a little tablet here. On this one, they do have some of the solutions worked out, but let me go over it. So the first question was, what was the lowest monthly total and when did this occur? So the lowest monthly total, you might think was like between these two, but actually the lowest monthly total means from the beginning, from 500 to whatever it goes up to. So that was this amount right here. The lowest monthly total that they ever sold was in December, and that was 550. So that's the lowest monthly total. I put number 1 here, December 550. Okay, the second question was, how many tires were sold during the first 3 months? Well, you could calculate, I did it 2 different ways. I added those up, and I can't find my work for this, but I added those up. Let's see, first month was 550. Then I went from 550 to 650, which was 100. And then I went for the last month, 550 for the first, 100 for the second, and then from 650 to 700 would be 50. And I had them all together and I got 700, which I could have just looked at the graph and said, well, these all total up to the total for March, which was 700. That's the sum total at this point, 700. It didn't mean they sold 700 in March. It was the total that they had sold in March. So that's what they were doing, is they were adding these up. And no, I guess I'm wrong. See, I was thinking of interpreting it that way, but I'm wrong. It should be 550. And then the next month they sold 650. And then the last month they sold 700. So the total for the first 3 months was actually the sum of those numbers. 0, 0, carry the 1. Let's say that'd be 13, 18, 1900 tires they sold in the first 3 months. That's why this was the lowest amount. 550. Well, actually, it's not 550, is it? It's closer to 575, kind of in between there. Let's change this a little bit. That would give me 25 more. 1925 is what I come up with. What do they come up with? They put 650, but I think it's, they said 580, and I said 575, 650, and 700. So I said 1925. The book says 1930. So again, it could be a little difference of the way they interpret. I thought this was closer, again, in the middle. So I put 575. Okay, then the last one, what they wanted to do, and this one's kind of the hardest one, and I'll show you what they did. Okay, it says, during which 2 consecutive months did the largest sales drop occurred, and by what percent did the sales decrease? So they said, if you look at this graph, there's a big fall between October and November. That was the biggest decline. So in October, they said there were 750 sold. And in November, there were only 600 sold. So the decline itself was 150. And they divided that, that's the change. And then they divided that by the starting amount, which was 750. Now they set it up as a proportion. I did it as a percentage like this, 150 divided by 750. I just did this amount divided by the change divided by, it started out at $750. So that was your starting amount. You divide that out and you get 0.20 and you change it to a percent. Change over starting amount. Okay. So they came up with the same figure. They just did it by proportion. I did it by kind of a percentage type thing. Okay, so that's the basic idea between interpreting graphs. I don't think yours will be even as difficult as those. The next thing we want to look at is measures of central tendency. And the measures of central tendency are lost and they're found. So I'm going to make this very big. The first one is the mean. Let's do this one. There's 3 measures of central tendency: mean, median, and mode. So what are we talking about? The mean. The mean is the sum of your data. You'd add up all your data. And then you divide it by how many pieces of data you had. So here's an example. You had these numbers in the book. This is what a mechanic, when he was trying to figure out how many hours he spent on a project. First time it took him 9.6, another time 10.8 hours, 10 hours. One time he finished fast, 8.5, another slow. So he added all those up, 1, 2, 3, 4, 5, 6, 7, 8, 8 numbers. He divided by 8. The sum of these numbers was 81.5. He divided by 8, and he came up with about 10.18 hours. A little bit more than 10 hours it usually takes him to do this job. So he can figure his labor on based on about 10. Sometimes he's going to take a little bit more and sometimes less. So this is what we call an average. When we're adding up all the numbers, we sometimes use a symbol called sigma. Looks like that. And that means the sum of. When you see this, it's called sigma. Greek letter, capital Greek letter. And it means the sum of these numbers. And then we divide them by how many numbers we had. There are 8 terms here. So we divide it by 8. Just like your grades in school. Say you had a grade of, we'll figure out your grades 3 different ways. Let's say on the quizzes, we do 10 quizzes, okay? You had a 40 on one, a 32 on another, 25 didn't do so good, a 40, another 40, 35, 36. How many is that? 1, 2, 3, 4, 5, 6, 7. Another 40, 38, and another 36. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So to find the average of these, we're just going to take those numbers, 40 plus 32 plus 25 plus 40 plus 40. Sometimes we don't want to put in too many because then we run out of space on our calculator. 35, 36, 40, 38, and 36. I think we can fit all that in. And we hit equal. And that's the total of all these 362. Then we're going to divide it by how many scores we had. We had 10 scores. So your mean is 362 divided by 10. 36.2. To get an A in this class, you need a 36 average on those quizzes. So this would be an A grade, even though you had one bad grade here, which was almost it was an F. You had several A's, perfect scores and stuff. So it equalized out. So that's all they mean by the mean. Add up all these numbers and then divide them by 10. So it's the sum of the 10 scores that you had. And that gives us our average score. The second way we can analyze our data is by the median. In the median, another commonly used central measure is the median. The median of a set of data is the middle of the data, the middle number in the data. Here they took a bunch of numbers and they have to rearrange them in order from the highest to the smallest, or the smallest to the highest, either way. And then they found the one right in the middle. And that is the middle number is your median score. So that's what they did here. They measured thicknesses and then they compared them. So let's find the median on yours. First of all, let's go from the smallest to the biggest, 25. And a good idea is to cross these off. We're not going to add them, so we'll put a comma, 32, 35, I think is the next, 36 twice, 38, how many do we have? 1, 2, 3, 4, 5, 6, and then there should be 1, 2, 3, 4, 40. So we're correct. 40, 40, 40, and another 40. So to find the median, we arrange these in order from the smallest to the biggest, or biggest to the smallest. It doesn't matter, but they have to be in a certain order. They can't be mixed up like this. Then we find a number in the middle by counting 1, 2, 3, 4, 5. But if we count from the back, 1, 2, 3, 4, 5, we end up with two numbers in the middle. So when this happens, we're going to add those two numbers together and split them in half. We're going to divide by 2. So 36 plus 38 equals 74 divided by 2 is 37. So if we took the median score, your median score is 37, which is still an A. So that's what we mean by the median, the one that happens right in the middle. Usually we like an odd number of data because then it's easier. You won't get two numbers in the middle. If both of these were the same, of course, then you add them together, 72, divide by 2, and you get 36. So if there's a tie, count 5 one way, 1, 2, 3, 4, and circle the fifth, 1, 2, 3, 4, 5, and circle the fifth. If there were 20, you would count 10 one way and 10 the other, and then circle, and then find the average of those two. And this is the median score. The last measure of central tendency is the mode. The mode is the one that occurs most often. Mode most often. It's the one that shows up. Sometimes there will be a number that they're all different numbers, and then that means there's no mode. If there's no mode. And sometimes you might have a number that comes up like 38 comes up twice and 36 comes up twice. So you could have both those numbers as your mode. Okay, they both happen 2 times. If there is no clear-cut number, that happen the most often. So no number comes up. Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We just have all those numbers and then they all happen one time. There's no mode. If we have 1, 2, 2, 3, 4, 4, 5, 6, 7, 8, 9, 10, then 2 and 4 would be the mode. So let's look at these. Here's one that they had a bunch of numbers and they looked through it and this 10.8 comes up twice. The rest of them only come up once. So 10.8 is the mode. It happened the most. Looking at your numbers, it's pretty clear to see 36 happened twice, but that's not the mode. The mode is the one that happened the most. 40, 40, 40, 40. So the mode, and we could either look at it this way or this way. This is a little quicker, how we can see all those 40s. The mode is 40. Don't write down 36 because it only happened twice. This happened 4 times. You don't have to put down how many times. You just put down the number 40. So mean is the average. Take the numbers, add them up, divide by how many numbers you have. The median, arrange them in order, and find the middle number. Median, middle. And mode is the most, the one that happens the most. Mean is the average. So there you have the measures of central tendency, the 3 measures: mean, median, mode. They all begin with M. And on the quiz, we'll probably have some problems where you had to find the mean, the median, or the mode, or maybe just like I did on this sample, you'd have to find them for all of them. So you see there's a big difference between these. When the mean, the median, and the mode are the same, and that's pretty good indication of your data. On this one, you notice the mean was the lowest, the median was in the middle, and the mode was the most. So this would probably be a pretty fair representative of your data because this score was an A, this score was an A, and obviously this score was an A. So the person definitely deserves an A. Okay, but usually we calculate your grades by the mean score. Okay, so what if we took this mean and we threw away the highest score and the lowest score? The lowest score was 25 and the highest was 40. What if we took those 2 away, 25 and 40? Then you'd have 65. So 362. And sometimes with data, that's what they do. They take away the highest score and the lowest score. Let's subtract here. I'm going to use my calculator so I don't make a mistake. I'm not asking for a problem like this. I'm just kind of showing it to you. They came out to 297, but we would divide that by 8 scores because we threw out 2. And in this case, it came out a little bit higher. The person would have 37%. So if we threw out the lowest score and the highest, when I'm calculating grades, I basically have thrown out your 4 lowest scores, which should boost up your average score quite a bit. We're not throwing out any high scores, just low scores. So this does have a tendency to bring up your average a little bit. Could be I made a mistake in grading, could be you made a mistake in interpreting the quiz, and so on. So to kind of help you out, at this point, I've thrown out 4 of your lowest scores, which would be in this case 25, 32, 35, and 36. So this person would definitely have an A. Okay, so that's kind of how things are done. A lot of times they will throw out the highest and the lowest to kind of get a little bit better average. And so sometimes they do it that way. And then sometimes they do it by mean, and sometimes they do it by mode. All right. I hope you interpreted I don't think you'll find this quiz to be too hard. And this is the last quiz that fortunately you have to take. So let me sign off here and